All right, welcome to another day of learning to program, and we're doing C Sharp. It was day 3, so let's go ahead and start how we've been starting and creating a new project. All right, create. And we left off on classes. So here we go.
Okay, here I have a blank console application and I want to create a class called person. So we can't create a class here inside the main method because that's a function or a method. So we need to create a class at the namespace level. So look, here we have a namespace and here's one default class. We can create another class at this level. So public class person code block. Now let's declare a couple of fields. So public string first name, public string last name. And now let's declare a method, public void, which means it doesn't return any values, introduce. And here I simply use console.writeLine to output the full name of this person on the console. So console.writeLine, my name is first name plus, I would like to add a space between them, and last name. Now let's create an object of type person.
We've already done this one. Yeah, we're on structs. Like that looked familiar. Okay.
In C Sharp, we also have another
a little memory jog of what we learned. So the previous class or day we learned about classes and we've practiced classes. So now we're learning about structs, and then we're going to go into arrays, strings, and test strings. And then we'll probably be able to finish the rest of this lesson today. Go ahead and try to put this down here without it. So
another type similar to classes, which is called structure or struct. So in terms of syntax, it's very similar to a class. The only difference is instead of using the class keyword, we use the struct keyword. So similar to classes, structures combine related fields and methods together. But what is the difference? If you read the C# documentation, you're going to see lots of tiny differences between classes and structures, and you're probably going to be even more confused than when you started. I personally don't find these subtle differences very pragmatic. In fact, in the real world, 99% of the time, you will create new types using classes, not structures. The pragmatic guideline I give you in this lecture is use a structure when you want to define a small, lightweight object like this RGB color here, or if you're dealing with something like a point that has an X and a Y. You can certainly define that using a class. There is no problem at all. But if you're in a situation when you want to create thousands or tens of thousands of objects of that type, it's more efficient to define them as a structure. If not, don't worry about it, just stick to classes, because that's what you use most of the time.
all right.
Another non-primitive type we have in C# is array. In this lecture, I'm going to give you a brief introduction of arrays to get you started. Later in this course, we have a separate section about arrays, and there I will cover more details. So what I'm covering in this lecture is what is an array, how to declare and initialize arrays, and how to access array elements. So what is an array? An array is a data structure that we use to store a collection of variables of the same type. For example, imagine you would like to work with 3 numbers. So instead of declaring 3 integer variables like number 1, 2, 3, you can declare an array and call it numbers. Note the square brackets here. The first one is used to tell the compiler that we would like to declare an array, and the second one is used to set the size of that array. So in C#, arrays have a fixed size, which means you need to specify it during declaration and it cannot be changed. Also note the new operator here. When declaring an array, you need to allocate memory for it, and that's why you need to use the new operator. Also, an array is an object behind the scene. So in C# we have a class called array, and when you declare an array using this syntax here, internally the compiler creates an instance of that class, so an object, and that's why we need to allocate memory for it. Now that we have an array, we can access its elements using an index that we supply in the square brackets. Note that in C# arrays are 0 indexed, which means the first element of an array has the index of 0. If you know ahead of time the values you would like to store in an array, you can use the object initialization syntax and make this code shorter. So during the declaration, you supply the values in curly braces. Again, this was a quick introduction to arrays, so you can get started quickly and write some simple programs. I'm going to cover arrays in more detail in a later section in this course. Now let's flip over to Visual Studio and do some coding.
All right.
Okay, in this video, we're going to take a look at how to declare and initialize.
Okay.
As an array in C#. So let's say we would like to create an array of integers. So we start with int. We use the square brackets to indicate that we would like to create an array, not just an integer. We give it an identifier or a name. And now we need to allocate memory to it. So we use the new operator and we repeat int array again. But this time we need to specify the size of the array. So let's say 3. Now we can make this code a bit shorter by getting rid of this int array here and just using var. The compiler knows that numbers is assigned to an integer array, as you see here. So there's no need to repeat that twice. Now I'm going to set the first element of this array, and because in C# arrays are 0 indexed, the first element starts with index of 0. So numbers of 0 equals 1. Now let me show you something. I'm going to display all the elements in this array on the console. So console.write line, numbers of 0. And I'm going to duplicate this line a couple of times with Control D, which is one of ReSharper shortcuts. And I change the index on each line.
That's not a ReSharper shortcut.
So this is a very basic way of displaying elements in an array. A more efficient way is to use a loop, and that's something we're going to look at in the next section.
That's important.
Now let's run this application and see what happens. So our array has 3 elements, and the first one is initialized to 1. But what about the others? Note that they're initialized to 0 by default. So that means when you declare an array, all the elements are set to the default value of the data type for that array. In this case, because our array is of type integer, the default value for integers or any kind of numbers in C# is 0. If we had an array of booleans, all elements in that array would be initialized to false. Let's try that. So I'm going to create another array. Let's call it flags. And this time I'm going to use a bool array. Again, the same size. Again, similarly, I set the first element. So flags of 0 equals true. And now I display all elements in this array. Let's run the application. So note that the first element of the Boolean array is set to true, but the second and third elements are false. Now, one more example before we finish this lecture. This time, I'm going to create an array of strings, and I'm going to use the object initialization syntax to initialize it during declaration. So, I'm going to call it names, new string array of size 3, and I'm going to store 3 names here. So, Jack, John, and Mary. So with the object initialization syntax, you start with curly braces and you supply values for each element of the array. That's pretty much it for this lecture. Later in this course, we're going to have a full section on arrays, and there I'm going to cover arrays in more detail. I hope you enjoyed this lecture, and thank you for watching.
Okay.
Okay, in this video, we're going to have a quick introduction to strings so you can quickly get started. And later in the course, we have a separate section where I cover more details about strings. So in this lecture, I'm going to cover what is a string, different ways to create strings in C#, and finally, I'm going to talk about escape characters and verbatim strings, which are pretty handy. So a string is a sequence of characters. And as you can see in this example, in C#, we surround strings with double quote, as opposed to characters which are surrounded by single quote. There are different ways to create strings in C#. A very common way is to use a string literal. So just like declaring a variable, we start with a type, in this case string, then an identifier, and finally we assign it to a string literal. We can also concatenate strings using the plus operator. So in this example, I'm adding first name plus a string literal which represents an empty character, and finally the last name. Sometimes using string concatenation this way can create a bit of noise in your code. You might have different string variables that you're concatenating, and it's hard to visualize what the output looks like. If that's the case, you can use string format. So in C#, the string keyword maps to the string class in the .NET framework. And you learn that classes can have fields and methods. And we can declare these members as static, which means we can access them directly on the class without the need to create an object. So in the example you see here, we're calling the format method on the string class. Format is a static method, so we can directly access it using string.format. This method takes a couple of parameters. The first one is a format string, which we use to define a template for a string. Inside this template, we have placeholders. Placeholders are indicated by curly braces, and they are 0 indexed. So here, placeholder 0 will be replaced by first name, and placeholder 1 will be replaced by last name. So as you see in this example, it's much easier to visualize the output as opposed to concatenating multiple strings together. Sometimes you might have an array of objects. You can create a string from combining all elements of that array using a separator. So in this example, we have an integer array with values 1, 2, 3. And in the second line, we are calling the join method of the string class, which is a static method, and we supply 2 arguments. The first argument, which is a string, is a separator. In this case, I would like to combine these 3 numbers using a comma. The second argument to this method is the array whose elements we would like to combine. Now that we have a string, we can access each of its individual characters using an index. So in this case, name of 0 represents the first character in our string. One thing you need to know about strings in C# is that strings are immutable, which means once you create them, you cannot change them. So back to our example here, we can certainly read the value of the first character in our string, but we cannot change it. So the third line here, which is indicated by red, is not going to be compiled. There are methods in the string class that allows us to manipulate strings and modify their values. But all these methods return a new string. So the original string is not changed. And that's what I mean by immutable. There are a few special characters in C# that sometimes have different meanings. For example, if you want to have a new line in your string, you need to use \n. When the compiler sees that, it automatically adds a new line. If you don't add the backslash, the compiler sees n just as the letter n. Same for tab. If you want to have a tab, you use \t. Now that brings us to an interesting situation. What if you want to use the backslash letter itself? Because when the compiler sees backslash, it thinks we are using a special character. So it's not quite sure. It might get confused. So if we want to tell the compiler that we would like to use the backslash letter, we need to represent that by double backslash. Same for single quotation mark and double quotation mark. We need to prefix them with a backslash. And that's what we call by escaping characters in C#. So these are special characters. The list of special characters, in fact, is even more than that. But personally, I have not found any of those special characters that you find in C# documentation pragmatic. Those you see in this table are the ones I have found very common. Okay, now because of these special characters, there are cases where creating a string can be a little bit messy. For example, look at this path variable here. Note all these double backslashes we have. It looks a little bit messy, doesn't it? The good thing is, in C# we have a kind of a string which we call verbatim string. And with a verbatim string, we don't have to use all these double backslashes. We can simply prefix our string with an @ sign, and as a result, we can get rid of all these double backslashes and just use a single backslash. Okay, now let's flip over to Visual Studio and do some coding.
Let's do this one.
Okay, let me start by creating a string called first name.
So let me go ahead and delete all this stuff. Just this thing is what we're going to delete, I think. So you say class. Okay.
So string first name equals mosh. Now, obviously, here we can use the var keyword because compiler knows we have assigned this variable to a string literal, so that should be of type string. So we can make the code shorter. So I put the cursor here. I can manually change that to var, or with ReSharper, Alt and Enter, and Enter. Now let me show you something interesting here. Hover your mouse over the var keyword. Note that this variable is of type string, which is a class that is defined in the system namespace. In the lecture about primitive types, I explained that all primitive types in C# map to a type in the .NET framework. For example, let's use the int and declare a variable like number. If you hover your mouse on int, you see that's of type int32. And note that this int32 is a structure. So all these keywords we use in C# like int, char, string, float, bool, they all map to a type in the .NET framework. The primitive types are all structures like this int or int32. But strings are classes. So let me remove this. Look at this one more time. So we have a class in the system namespace which is called string. What this means is you can create a string like this using the string keyword in C#, or you can use the string class in the .NET framework. The difference is when you use the string class, you need to import that namespace, the system namespace on the top, because here we're writing code inside this namespace, but we're accessing a class that is in a different namespace, the system namespace. So if you have ReSharper, you can automatically import that. Otherwise, you have to go on top of the file and type using system semicolon. So whether you use the string class like this example or using the string keyword, it's exactly the same. There is no difference. And that's one of the things that confuses beginners to C#. Similarly, you can create an int32 using the int32 structure in .NET Framework. Call it I. Or you can use int keyword. They're essentially the same thing. Okay, now let's clean up all the extra noise here and get back to our example. I'm going to change this to var to make the code cleaner. So one way to create a string is to use concatenation. So we can declare another string and concatenate 3 strings together. But as I explained, sometimes it's hard to visualize the output, and we can use the string format method. So here is an example. So string, again, maps to the system.string class, and this class has a bunch of static methods, as you can see here. So these methods are accessible without the need to create an object. They're accessible directly on the string class. For example, you can use the compare method to compare strings. In this case, we're going to use the format method. So this method takes 2 arguments. The first one is a format string or a template, something like this. And the other arguments are values to supply to this template. So I'm going to pass first name and last name. At runtime, what we have here will be replaced by first name. Same, what we have in here will be replaced by last name. Now let's take a look at string.join. So I'm going to create an array of names. And I'm going to create a string by combining all these values using a comma as the separator. So we use the join method. Again, it's a static method on the string class.
Yeah, I'm going to pause it really quick here so I can catch up. It's going too fast. Oh no, I can't see. Okay. Let's see. So he's got John. Jack. Mary. So this be used. There. Are formatted names equals string. Dot. Okay. We're caught up.
We use the join method. Again, it's a static method on the string class. The first argument is a string, which represents a separator. You can use comma. And the second argument is the array. So names. Let's display the result on the console. So formatted names, just like that. So you see John, comma, Jack, comma, Mary. This is a very useful technique when you have some values and you would like to combine them together using a separator. Now let's take a look at verbatim strings. So I'm going to create a string that has multiple lines and has a few paths. So something like this.
Did it. This stuff is just an exercise so you know how to type it out and stuff like that. It's not really that difficult to write this stuff. It's very basic fundamentals, but it's good to know, how to write vars and or all these strings and stuff like that. So obviously that's what the course is called. It's called Fundamentals to C Sharp. So this is very basic stuff.
This string is very unreadable. So you see the output first, and then I'm going to show you how we can clean this up using a verbatim.
Let's go ahead and type out everything he's saying. 1, 2, C, folder 3. Okay, so that's kind of what he wrote. This is actually back one there. Okay, so let's go ahead and run it.
String. So instead of displaying formatted names, I'm going to display the text here.
Oh. I forgot how he puts stuff down. Oh, we'll just. I think he ended up getting rid of that, putting that there. Oh, that's all you ran.
So this is the output. Hi, John. Then on a new line, look into the following paths. Then on 2 new lines, we have 2 paths here. As you see, using a normal string is very hard to format something like that. So we can use a verbatim string. All we do is we prefix it with an @ sign. Then we don't need \n. We can simply put that on a new line. Same here. Remove the \n on a new line. And we can remove all these double backslashes. So you see, it's much easier to read and understand this string. So whenever you need to use \, new line, or tab, use a verbatim string to properly format your string. So that was a quick introduction to strings to get you started.
I don't know. I think that looks gross, personally. If there's a way to set it to where it's like actually underneath this stuff, that'd be nice, but I feel like it's just gonna. See what this looks like. Yeah, that looks gross. I don't like that. I don't know why would you want to format it like that. Like, unless there's a way to clean it up, but that code looks icky. Looks icky, man. I don't like it. Oh well. Okay. Well, that's the end of that lesson. We'll go ahead and delete some of this stuff.
Later in this course, we have a separate section where I'll cover more details about working with strings. I hope you enjoyed this lecture and thank you for watching. Okay, another type.
Let's see here.
We're going to cover in this section is enums. An enum is a data type that represents
We gotta bring this over here.
a set of name value pairs or constants. Let me show you where you use enums in the real world. Imagine you're building an application for a post company and you want to support a few different shipping methods. So, one way is to declare a few constants, each representing a shipping method. And in your application, based on the shipping method, you can make decisions to calculate the shipping cost or the tax or display different messages to the user, so possibilities are endless. Now, even though this approach works, it's a little bit messy. It's better to define a new type where we can represent different shipping methods. So that's where we use an enum. So we can create a new enum called shipping method with these three members. So in simple words, use enums where you have a number of related constants. Instead of declaring multiple constants, declare an enum. This will be a new type in your application, just like we have classes or structures. Okay, now that we have an enum, we can use it with the dot notation.
All right.
Now, one thing I want you to know here is that an enum is internally an integer. But if you have a reason to change that and use a byte instead, perhaps it could be easier for you to map in your database columns, then you can specify byte during declaration of your enum. So that's the basic idea about enum. Now let's flip over to Visual Studio and let's see how to work with enums. Okay, now I'm going to create a new enum called shipping method. Note that because enum is a new type, we need to define it at the namespace level. So
really fast.
Now, if we don't set any values to the members of this enum, the first member is going to be automatically set to 0. And from there, every member's value will be incremented by 1. Now, in terms of best practices, I suggest always explicitly set values for these enums because it's very likely that somewhere in your database, you might have a table that represents this enum. So you want to make sure the IDs or the values you assign to these enum members match to the records you have in the database. If you rely on the automatic value assignment, and sometime in the future add a new member to this enum, the value of some of the existing members may change and may no longer match the records in the database. So, okay, now we have a new enum, it's a new type, and we can use it when declaring a variable. So in the main method, and here we use the dot notation. Note that IntelliSense shows us all the members in this enum. So let's set it to express. Now I told you that internally an enum is an integer. So I can easily cast that to an integer if I want the numeric value of this enum. So let's display the numeric value of this shipping method on the console. So I put method here and then cast it to an integer. Let's run the application. So the value of express is 3. Now there are times that you receive a number from another system. It could be your database or it could be a third-party application supplying some data. And you need to convert that number, that integer, to a shipping method in your application. In situations like that, again, you can use casting to convert an integer to a shipping method. Let me show you what I mean. So imagine we received the number 3 from somewhere else. And we want to convert that to a shipping method. So we can use casting, shipping method, and put method ID here. Let's look at the result. So you see, the number 3 represents the express shipping method. So these are two examples to convert an enum to and from an integer. What about the strings? There are times that we need to convert an enum to a string, or get a string and convert it to an enum. Let's take a look at two more examples here. So I'm going to convert this method here to a string. So method dot, look at this method here. Every object in C# has a method called toString. So technically, you can convert anything to a string without doing any extra work. So all I have to do here is just to call the toString method. And when we run the application, we're going to see express on the console. There you go. Look at the third line. Okay, now as a tip, console.writeLine by default always calls the toString method on any value you pass to it. So in this example, even if I didn't call toString, console.writeLine would still convert that enum to a string. But in case you're not using console.writeLine and you want to explicitly convert that enum to a string, then you can use the toString method. So I'm going to revert this back. And final example. What if we have a string and we want to convert that to an enum? Again, the reason could be we have that string stored somewhere in the database or in another system. So something like this. We need to convert this method name to a shipping method enumeration. How do we do that? Well, before I show you that, I want to introduce you to a new term, parsing. Parsing in programming means getting a string and converting that to a different type. So we say we parse the string, which means we convert that string to a different type. So technically here, I want to parse this string into a shipping method. How do we do that? Well, we have a class in .NET called enum. This class is defined in the system namespace. So if you don't have using system on the top of your file, you need to add that here. Now this class has a number of static members. So if you put dot here, we can see it's static methods. And look, here we have a method called parse. Let's look at the parameters of this method. So open the parentheses again. So this method has two versions, which we call toOverloads. The first one takes 2 parameters. The second one takes 3 parameters. Let's take a look at the simpler one. So the first parameter is a type object. What is a type? Type is a class in .NET that represents metadata about other types. As a pragmatic tip, whenever you see the type object, you can use the typeOf operator. So look, typeOf, this is a keyword, this is an operator, and takes a parameter. So here we need to specify the target type that we want to convert this string to. What is the target type here? Our shipping method. So shipping method here. Now look at the second parameter of this method, string value. So here I pass method name. Now look at the return type of this method. It returns an object. It does not return a shipping method. So we need to cast this object to a shipping method, which means I go to the beginning of the line, use cast here, shipping method. And now I can store the result of this expression into a different variable. Let's call it shipping method. I forgot the semicolon. There you go.
How dare you?
Now, if I hover my mouse over var, look, the type of our variable is a shipping method. So this is how you convert or parse a string to an enum or enumeration.
Oh, okay. That's it. So if I didn't write it out, it's going to be kind of hard to talk about it. But it's okay. We'll go ahead and just go into the next one.
Okay, so far we have talked about various data types in C#. We looked at primitive types like integer, character, float, bool, and a few non-primitive types like classes, structures, arrays, and strings. And I told you earlier that both strings and arrays are classes. So I showed you during one of the demos that the string keyword maps to the string class in .NET. And same goes for the array notation that maps to the array class. Now, that brings us to an interesting topic. In C#, essentially we have two main types from which we create new types. We have classes on one side and structures on the other side. So every type you have learned so far is either a class or a structure. So all primitive types are structures. Remember I told you use structures for small types like RGB color and point. Well, all primitive types are very small types. They take no more than 8 bytes. That's why they are internally defined as a structure in .NET. Arrays and strings are both classes. We can also create custom classes like person or calculator. Now, in C#, these classes and structures are treated differently at runtime in terms of memory management. And that's what I'm going to cover in this lecture. I want you to understand what happens under the hood in memory, so if your program does not behave the way you expect, you'll be able to troubleshoot it. Structures are what we call value types, while classes are reference types. When you create a variable that is a value type, a part of memory called stack is allocated for that variable. This memory allocation is done automatically, so you don't have to worry about it. When this variable goes out of scope, it will immediately get removed from the stack by runtime or CLR. With reference types, however, you, the programmer, need to allocate memory yourself. Remember the new operator? We use the new operator with classes. So when we use the new operator, we tell the runtime to allocate memory to this object. And this happens from a different area of the memory called heap. This memory, unlike stack, is more sustainable. So if you create an object and that object goes out of scope, it will continue to exist in the heap for a little while. It won't be removed immediately. There's a process called garbage collection, which is done by runtime or CLR, that takes care of this. So once in a while, CLR looks at the objects that are no longer used and removes them from the heap. Now, this was the theory behind value types and reference types. What you need to know in pragmatic terms is when you copy an object to a new variable, depending on whether that object is a value type or a reference type, there will be two different outcomes. And it's much easier to show this in code. So let's flip over to Visual Studio and see how copying value types and reference types are different.
Okay, so this next one is going to be kind of important. It's talking about, the back end of memory and stuff like that. It's like if you're programming a game and stuff like that, you can see how much memory the program's using. I think that's what we're going to be learning. I hope so. Be cool. Let's go into it then.
Okay, in this video, I'm going to show you reference types and value types in action. I'm going to use two different examples.
I wonder if we should type this one out. I think I will. Let's see. Yep.
So I'm going to start with a simpler one. First, I'm going to create an integer variable. So a is 10. Now I'm going to create another variable called b and copy a to b. And finally, I'm going to increment b by 1. So I'm going to use the increment operator. Now I got a question for you. What do you think the value of a is going to be at this point? Is it going to be 10 or 11? The answer is 10, because integers are value types. So when we copy a value type to another variable, a copy of that value is taken and stored in the target location in memory. So let's verify this. I'm going to use.
So to explain what you just said in more layman's terms, just because A is here, it won't change it up here. A is 10, but B equals 10, or B equals A, so technically B is also 10, and then this is B plus 1. So, if that makes sense.
Use console.writeLine. And here I'm going to display A and B on the console. What is a good way to display A and B? We can use string format. Remember string format? So string.format. Here we supply a format string. So 0 and 1 here are placeholders. And now we supply arguments to fill these placeholders. So A and B here.
Let me go ahead and type
now
this
let's run the
really quick before he runs it. He's typing a lot faster than me. 0. Oops. 0. This is where practice makes perfect. He types like super fast. But if you practice this stuff, and that's kind of why I'm typing it out, practice, you'll be able to get better at it. A, B. I don't think we need this one.
Location.
Yep. Okay, so we need to put a comma right before this stuff. There. I think that's it. Oh. Okay. Let's run it.
With Control and F5. So look, A is 10 and B is 11. So the lesson is when you copy a value type to a different variable, a copy of that value is taken and stored in the target variable. That's why we call them value types. Their values are copied. Let me show you what just happened in memory. So imagine.
Okay, let me go ahead and bring this over because he's showing us a thing.
Here is the stack, and somewhere in the stack we have a location identified by A, and in that location we have the value 10. When we copy A to B, a new location in memory in stack is created, identified as B, and the value we had there in A is copied to B. That's why these two variables are now completely independent, and making a change to one does not impact the other. Now let's see reference types in action.
All right.
So this time I'm going to create an integer array. And as you know, in C#, an array is a class. So it's a reference type. So let's create array1. And here I'm using the object initialization syntax to initialize my array with 1, 2, 3. Now I copy this array1 into another variable called array2. And finally, I'm going to make a modification to array2. So let's say I want to set the first element to 0. At this point, what do you think is going to be the first element of array1? Is it going to be 1 or 0? It's going to be 0. Let's go back to the memory.
Stop. I'm not ready. I'm not ready. 0. Oop. So I think he's gonna say 1 is 0 because the way programming counts is it starts with 0 and then it goes 1, 2, 3. So that's probably what he's gonna say. Let's go ahead.
Element of array1. Is it going to be 1 or 0? It's going to be 0. Let's go back to the memory visualization again and see what happens when we run this code. So here we've got stack and heap. When we create and initialize array1, this is what's going to happen. First, an object is going to be created on the heap. This object is in a memory location with the address you see here. And inside this memory location, we have the actual array with 3 elements, 1, 2, 3. Next, the runtime or CLR creates a variable on the stack identified as array1. The value inside this variable or inside this memory location is a memory address. And that's the address of the object on the heap, the actual array. So array1 points or references the object on the heap. So this is what happens when we create and initialize array1. Now let's see what happens when we copy array1 to array2. So the runtime creates another variable on the stack identified as array2. And again, inside this variable, we're going to have a memory address. And as you see in this picture, this address is the address of the object on the heap. That's why both array1 and array2 point to the same object, which means when we make any changes on this object on the heap, either through array1 reference or array2, the changes are visible through the other variable. That's why we call these types reference types. So when we copy them, their reference or their memory address is copied, not the actual value. So back to the code, let's verify this. Again, I'm going to use console.writeLine and string.format.
We'll just let him finish it up.
So I display the first element of both array1 and array2, and they both should be 0. Let's run the application. They both are 0.
Okay. So let him do this one. It's 4 minutes long. And then we're almost done with this lesson, actually. Yeah, this is the last one. So, woohoo.
Okay, let's take a look at another example of reference types and value types in action. So in this code, I have defined a class called person with one field called age. And inside our program class, I have defined two methods, increment and makeOld. The return type of both these methods is void, which means they don't return any values. And the reason I have defined both these methods as static is simply to call them without the need to create an object. Just want to keep things simple. So in the main, first I'm going to create an integer called number. And I set it to 1. Now I'm going to call the increment method and pass my number variable as an argument. So the increment method takes a parameter of type integer called number and adds 10 to it. Note that here I'm using the addition assignment operator to add 10 to the number that is passed to this method. Now, at this point, what do you think is going to be the value of our number in the main method? It's going to be 1, because this is a value type, and when we pass this variable as an argument to the increment method, a copy of this variable is taken and sent to the increment method. So interestingly, even though these two variables have the same name, but they are in two different locations in memory. One is the number with the scope of the main method. So outside the main method, this variable does not have a meaning. And here we have another number, coincidentally have the same name, inside the increment method, but that's a different place in memory, and its scope is limited to the increment method. So when this increment method is called, that new location is created called number, its value is incremented by 10, and then it's immediately destroyed. Now let's verify this. So I'm going to use console.writeLine and display number. We run the application. So our number is 1. It's not affected by the increment method. Now let's take a look at an example of a reference type. So this time I'm going to use our person class. So I create a person object and use the object initialization syntax to set its field. So this person is 20 years old. Now here we have another method called makeOld that takes a person object and adds 10 to its age field. So note that here, because the type of this parameter is a reference type, the object that is going to be passed here is not going
This
to
guy's
be
about to
copied.
tell me that I'm old.
Its reference is going to be copied, which means both the person object we have in the main method and the person object that we have as a parameter to this method will be pointing to the same object on the heap. Okay, so if I call make old and pass this person object, upon returning from this method, the age of this person is going to be 30. Let's verify
that's not
that.
Old.
So person.age. And let's run the application. There you go.
Stupid. That's not old. Don't worry, guys.
That's it for this lecture. I hope you enjoyed it, and thank you for watching.
All right, we're on the quiz. Let's see if we can get it done. What is the correct way to declare an int array? Int numbers equals new int. This one? No? Oh, man. Why? Why is it this one? They're all like the same. Oh, okay, I see it. The 3. Duh. I'm stupid. Okay. The output of this code. That previous course we determined that would be 0. Yeah. How can we access the first element in this array? Numbers, first numbers. 0? No. Should be this one. Is it this one? Okay. Oh, duh. I knew that. Fuck. Stupid. We have a class as follows. Public class point. Public int x. Public int y. How can we create an object of type point? Check. Nope. I did those wrong. Man, I'm horrible at quizzes. The N escape character is a string represents a line break. Hey, we got that one. Var number equals 1, var number 2 equals number 1, var 2 plus right line number 1 would be 1. We have an enum as follows. Public enum customer type bronze, silver, gold. Output of this code. Var type equals int. Customer type dot bronze console right line type. Would it be bronze or 0? I think it's bronze. No. Dang it. We're going to continue. We're not going to retry the quiz. Let's get a summary of what we learned today.
So in this section, you learned that we have two main categories of types in C#. On one side, we've got classes. On the other side, we've got structures. Examples of classes are strings, arrays, or any custom classes that you create. Examples of structures are all the primitive types like integer, character, float, and any custom structures that you create. The difference between the two types is purely memory management, and you can review that again in the lecture called Reference Types versus Value Types. Now, from the next section, things start to get really interesting, because I'm going to teach you about control flow, and you'll be able to write simple C# programs. And then in each section, you will learn something new about C#, and you'll be able to write more interesting programs. So I will see you in the next section.
Nice. It's going pretty good, I think, so far. We're gonna pause it. No, stop. Pause. So I'm gonna go through back here. So that section is completed. That one was an hour long. The one before was an hour long. This one's 41 minutes long, so we should be able to do this whole section on Thursday, which is cool. We got this one that
is 4 bytes and
thinks
long
that we're
is
not
8
done
bytes.
with it.
Okay, enough theory. Let's jump into code and see all this concept in action.
There. Now this section's done. No, stop.
Okay, let's see
Let's go over here.
the C# language and the .NET framework and run your application.
There. Okay. Cool. Now we got all those sections completed. We got 39 out of 96 courses completed. And then we got these.
For the next lecture.
Just skip these. But asking question, okay. Okay, so I can't change section 1 for some reason. Oh, well, guys, I'm gonna go ahead and call it. That's our day 3 of programming together. So thank you all for stopping by, and I'll see you on the next one.